All right, hello. So in this video, we're going to talk about applications of zero product property and zeros from equations. Specifically, we're going to talk about a quadratic polynomial and application problem involving a rectangle. But first, we need to define function, domain, and range. So for a function, usually you'll see this represented with this notation, f of x. That's what that means. And usually, a function will have some type of input and output values. Okay, I'm going to explain what that is. And domain is usually the set of x values. Okay, set of x values. And range is the set of y values. Okay, and the variables x and y could change, right? I also want you all to take note that when I mean by set of x values, whatever our input is, okay? And then whatever our set of y values is usually our output, okay? Now, the best way for me to have you all see this is with a t-chart. So usually you've seen x and y t-charts, okay? What you all should get used to as well is that y is equal to the same thing as f of x. And f of x is represented as the output. Let me go ahead and do this. So we can say that this is the output. And then x is usually your input. Okay? And that could be something like, let's just say that we have a set of values. I don't have the actual function equation, but let's just say that we have input values. We have 2, 4, 3, and 6, right? And then for instance, when x is 2, our output will be -3, okay? I'm making up these numbers. They're not coming from anything but from my head, okay? So, and then when x is 4, let's say we get 6. When x is 3, we'll get -1, and when x is 6, we'll get 6, okay? So these are just examples of input and output values, okay? And usually you'll see it as a graph, right? So if you were to go ahead and plot these, and, well, we have some negatives, so, ooh, so bad. So here we go. So we have 2, and then to -3, and then 4 to +6. So 1, 2, 3, 4, 5, 6. And then 3 to -1, and then, well, 1, 2, 3, 4, 5, 6, and then 6 to, well, hold on. Let's make this 5, because I just made that up. Okay. And then we have 5, right? So it looks something like this. I don't know. This could be some weird polynomial shape if we were to connect them in some way, right? Okay, so that's an example of what a function could look like. We've just happened to work with quadratics, and those make a lovely parabola shape, okay? So if this point didn't exist, and if it kept going like this and kept going up, it could have been a parabola. But all I really want you all to know about this is that domain is a set of x values, and range is a set of y values. And it's an important note here that for a set of values to be a function, each x value, no, that says each x value, has to go to 1 and only 1 y value. Okay, so for instance, if I had like so each x value has to have a unique output value. So let's say if I had like another 2, for instance, and I don't know, 7, then this wouldn't work because there was another 2 up here. So the x values have to be different, okay, in order for it to be a function. So Now that we kind of got that in our heads, that we have our domain is our x values, let's go ahead and check it out how this looks like really in a word problem. So here we have the length of a rectangle is 5 inches more than twice a number. The width is 4 inches less than the same number. If the area of the rectangle is 5 inches squared, what single value of the domain will make the area of the rectangle equal 15 inches squared? Okay, so there's a lot of words, and we have to be problem solvers and try this out, okay? So here we have, if we're talking about anything that has a picture or a shape in my word problem, I always like drawing a picture. So let's go ahead, since we're working with a rectangle, I'm going to draw a picture. Cool. I'm not going to label anything yet. I'm just going to try to remember like what we're talking about area. So what I remember about area is its length times width. All right. Okay, so then what do I know about the length? The length of the rectangle is 15 inches more than twice a number. Okay, so then that just tells me that we have some number that we don't know. So we have an unknown. So I'm going to call that x. I can barely see this, but an x. And then it's twice that number x. So that means 2 of x. Twice 2 of x. So I can label this as length on my picture. And that is the same thing as 2x. And it's 5 inches more than this. So it's plus 5. Oh, okay. That's a binomial. I've seen that at some point. Cool. Let's move on to another piece of information. So the width is 4 inches less than the same number. The same number, well, I gave this number x, and then the width is 4 inches less than that. So that just means I have width, and that same number is 4 inches less. So less than means minus, so minus 4. Oh, look, there's another binomial. Cool. All right. What other information do I know? If the area of the rectangle is 15 inches, okay, let me pause right there. So area of the rectangle. Area, they gave that to us already. So the area is what's inside, and it's 15 inches squared. Great. Cool. That's all I can do with that. And then this is the main thing. This is kind of weird. What single value of the domain will make the area of the rectangle equal 15 inches squared? Domain. Okay, what did we just say? Domain says a set of x values, which is the input. So maybe what it's saying here is what single value of the domain. Oh, okay. So this just means what value of x could make this equal 15 inches squared. So really, this is code for value. What value of x will make the area equal to 15 inches squared. That's exactly what this means right here. Okay, single value. So that tells me that I'm going to have to pick one number that will make this true. Okay, so cool. Let's go ahead and set this up. We have everything that we need. We have our structure. So my area is 15, or my length is, let's start with this. So 2x plus 5 times my width, which is x minus 4, is equal to 15. Okay, so if I need to figure out my x values, well, I remember I have to get one side equal to 0. But if I can't just subtract 15 from these two binomials. So I need to go ahead and multiply this first. I'm going to do some scratch work on the side. Okay, so I'm going to do box method. And I have 2x plus 5, and then I have x minus 4. When I do that, I get 2x squared, positive 5x, negative 20, and then negative 8x. Great. So once I combine like terms, I get 2x squared minus 3x minus 20 equals 15. All right. Well, to find x, I need to get one side equal to 0. So I'm going to subtract 15 on both sides. And I'm going to get 2x squared minus 3x minus 35 equals a 0. Great. Now I have to find x again. Okay, wait. So this means I need to get two binomials. So two binomials, I need to factor. Cool. So now I have to do reverse box method. Okay. So first I used it to multiply. Now I'm going to use it to do reverse box method. So here we go. So I know now the inside is 2x squared, and then this is negative 35, and they need to, my middle terms need to add up to be negative 3x. All right, so I'm going to do my t-chart. What 2 times negative 35 is negative 70. So what two numbers multiply to give me negative 70, but add to give me negative 3? Well, 7 times 10 works, and 10 would need to be negative. So 7 minus 10 does indeed give me negative 3. Oops. So that works out. Okay, so then what I can go ahead and do is put negative 10 here, or I should probably not do that. I should probably put negative 7 there. Okay, or positive 7x and negative 10x. All right, and then at that point, I can find my sides. So here I get 2x, and then x, and then plus 7, and then 7 times what gives me negative 35 minus 5. Double check my last box. 2 times negative 5 does give me negative 10. Cool, these are my two factors. So I get 2x plus 7, and then x minus 5. All right, so this is my question, what value of x? I'm almost there. All right, so I gotta set each of these equal to 0. So x minus 5 equal to 0. And I gotta isolate my x values. So subtract 7, I get 2x equals negative 7. Divide by 2, x equals negative 7 over 2. Cool, got one x value, plus 5, and then x equals 5. Okay, one of these is going to work and make sense in my problem. So what I need to do is go ahead and check. So I'm going to go ahead and check over here. Right, so I have, so let's say we have 2x plus 5 times x minus 4 equals 15. All right, so when x equals negative 7 over 2, I'm going to substitute that in to see if that actually works. So negative 7 over 2 plus 5, and all of this will be times, right? Negative 7 over 2 minus 4 equals 15. All right, so let's go ahead and do that. So 2 times negative 7 is negative 14 over 2 plus 5, and then negative 14 over 2 is negative 7 plus 5, and then I would get negative 7 plus 5, which is negative 2. But this doesn't make sense, right? Because this is supposed to be my length. Can I have a negative length? And no, that makes no sense. Makes no sense. So this means that this wouldn't work. So I can't have a negative value for my length, okay? I can't have a negative value for my x, but when I combine everything, I shouldn't get a negative number. So I can actually stop myself right here and say that doesn't make any sense. So let me go ahead and check this next one. So then I'm going to go ahead and do that. Let's see, we have 2x plus 5 again. This is my second check. And times that x minus 4. And I'm going to substitute 5. Okay, so I have 2 times 5 plus 5. And then 5 minus 4. And I'm going to see if it gives me 15. 2 times 5 is 10. 10 plus 5 is 15. 4 minus 4 is 1. That is indeed give me 15. So my answer is, what single value of the domain or what value of x would work? Well, that is 5. So my answer is x equals 5. Great, cool. So what I'm going to have you all do is go ahead and write down your summary with any questions that you have for your teacher and what you learned today about range, domain. Range we didn't talk about in this example. We'll talk about that on Thursday or Friday. We'll pay more attention about that later. But for right now, it's just domain and applying it into these application problems.